There are moments in science when the curtain of the universe lifts just enough to reveal something truly extraordinary. And when that happens, even the most seasoned scientists are left in awe. One of those moments happened recently when the James Webb Space Telescope captured an image that's already being described as one of the most important in human history. The clarity, the depth, and the implications of this image are so profound that it compelled Michio Kaku, a physicist known for his calm rationalism and bold predictions, to speak out. And what he said is sending ripples across the scientific community. Michio Kaku has always been a voice at the edge of scientific exploration. He's a visionary, someone who doesn't just look at what we know, but constantly imagines what could be. But this time, it's not a theory or a speculative thought experiment that's caught his attention. It's real data, visual evidence from the JWST that appears to upend some of our most foundational ideas about the cosmos. And for someone like Kaku to call it a moment that forces us to rewrite the narrative of the universe, you know something big has been found. The James Webb Space Telescope, since its deployment, has been nothing short of revolutionary. Unlike the Hubble, which observes mostly in the visible and ultraviolet spectrum, Webb looks deep into the infrared, allowing it to peer farther back in time than ever before. This means it can catch the faint light of galaxies formed just a few 100 million years after the Big Bang, light that has been traveling through the cosmos for over 13 billion years. It's like looking into a time machine that shows us the universe in its infancy. But no one expected what it just revealed. The image in question shows what appears to be a fully formed, massive galaxy, an impossibility according to current models of cosmology. This galaxy isn't just a cloud of gas starting to come together. It's structured, it has arms, it has mass. It seems to have undergone billions of years of evolution. But it's sitting in a region of space that should only be populated by primitive, newly forming structures. It's like finding a skyscraper in a village that was supposedly just founded yesterday. And this isn't just one anomaly. Webb has been capturing more of these galactic giants, mature galaxies at a time when the universe should have been a chaotic mess of particle soup and early clumping matter. For decades, the standard model of cosmology has told us that the early universe was slow to organize, that it took billions of years for matter to cool, coalesce, and evolve into complex structures like spiral galaxies. But now we're seeing evidence that this process may have happened much faster, or followed rules we don't yet understand. Michio Kaku's reaction to this image wasn't just one of amazement. It was a challenge to the scientific community. He pointed out that our understanding of the early universe is based on extrapolations and theoretical models that, while supported by observation, are still incomplete. The discovery of these mature galaxies so early in the timeline could mean several things. It could mean that galaxy formation began much earlier than we thought. It could mean that dark matter or dark energy behaved differently in the early universe, or it could mean more radically that the Big Bang model itself needs to be re-examined. He didn't say this lightly. Kaku has always supported the Big Bang theory, but he's also one of the few scientists who openly discusses the possibility of a multiverse of higher dimensions, and of a cyclical universe where time and space are more flexible than we imagine. So when he suggests that this image might be the key to a new cosmological model, it's not coming from a place of hype. It's coming from deep scientific curiosity. The implications are massive. If these galaxies truly are as old and massive as they appear, it raises questions about how structure forms in the universe. Did stars and galaxies form faster in the early universe due to unknown forces? Are we missing pieces in our understanding of gravity at extreme energies? Or are we seeing the results of a previous universe, a cosmic echo bleeding into our own? Kaku emphasized that science thrives on anomalies. It's the unexpected results that push science forward. When data doesn't fit the model, you don't ignore the data, you update the model. And what Webb is giving us is data that simply doesn't fit. These galaxies existing in the cosmic dawn shouldn't look the way they do. And yet, there they are, challenging everything we thought we knew. He also highlighted the importance of humility in science. Every generation of scientists thinks it has most of the answers, but time and again, the universe surprises us. The Earth wasn't the center of the cosmos. Newton's laws weren't the final word on motion. The atom isn't indivisible. And now perhaps the Big Bang model, as powerful as it is, isn't the complete story. This is just the beginning. The James Webb Space Telescope is only in the early stages of its mission. Over the coming years, it will continue to look deeper and farther, collecting data that could confirm or completely reshape our understanding of the cosmos. And as it does, more voices like Michio Kaku's will join the conversation, scientists, theorists, philosophers, trying to piece together a new picture of the universe. This new image, in many ways, is a mirror. It reflects not just the ancient light of the universe, but our own quest for meaning. It shows us how far we've come in our ability to see and how much further we have to go in our ability to understand. And that's what makes this moment so powerful. It's not just about what's out there, it's about what it means for us, here, now, looking up and wondering. The mystery deepens when you consider that these early galaxies seem to be chemically enriched, containing elements like oxygen, carbon, and even heavier metals. That alone is shocking. According to the traditional model, the early universe consisted mostly of hydrogen and helium, with heavier elements only forming inside stars through nuclear fusion and then spreading via supernova explosions. But this process takes time. So how is it that galaxies so young, so close to the Big Bang, already possess these elements? Did the first stars form, live, and die far faster than we expected? Or is something else going on entirely, something we've never seen before? Kaku suggested that this image might be a glimpse into a stage of the universe we've never fully theorized. He proposed the possibility that the early universe was not as simple as we imagined. Instead of a slow, gradual process of galaxy building, perhaps the early cosmos underwent periods of rapid and chaotic formation, cosmic growth spurts that defy the smooth, linear expansion models we've been using for decades. This would require rethinking everything from the rate of cosmic inflation to the behavior of dark energy. In his discussion, he also revisited the idea of a multiverse, not in the science fiction sense, but as a serious cosmological framework. If our universe is just one of many, it's possible that some of what we observe, like impossibly early galaxy formation, isn't a product of our universe's own timeline at all. Maybe we're witnessing evidence of an interaction with another universe, or relics from a cycle that preceded our own. These are wild possibilities, but not outside the realm of modern theoretical physics. One thing Michio Kaku made clear is that we must remain open-minded. Too often, science clings to the safety of established models, but the true breakthroughs come from data that doesn't conform. The James Webb Space Telescope was built not to confirm our beliefs, but to challenge them. And this image, this strange, ancient galaxy, may be the first of many clues that rewrite the cosmic story. Another key point he addressed was the concept of time itself. Time, as we understand it, may not be a universal constant. Einstein showed us that time bends and warps with gravity. Kaku takes this further by suggesting that in the earliest moments of the universe, time may have functioned in ways we don't fully grasp. If time itself evolved or was influenced by dimensions beyond our own, then perhaps the timeline we use to measure galactic maturity doesn't apply the same way at cosmic dawn. What we think is 500 million years might represent a vastly different scale in the framework of a universe shaped by higher dimensional physics. He also touched on the limitations of human perception. As advanced as our instruments have become, they're still extensions of human design, built around the frameworks we understand. Webb is showing us things we never imagined, but perhaps it's also showing us how limited our imagination has been. Maybe we've built a cosmic story too, focused on what we can explain, and not enough on what's truly possible. One of the more philosophical angles Kaku explored was the idea that the universe may be fundamentally unknowable in a complete sense. That doesn't mean we should stop trying, but that every answer leads to new questions. Every discovery opens a dozen new mysteries. This galaxy, captured in stunning detail by JWST, may be our latest invitation to re-examine not just the cosmos, but our place within it. It's a reminder that even the most confident models are just stepping stones meant to be surpassed. And this is where the beauty of science really shines, not in certainty, but in exploration. Kaku urged young scientists, students, and dreamers to see this discovery not as a disruption, but as an opportunity. The universe just got weirder, and that's exactly what makes it worth studying. Each new image from Webb is a page in a story we didn't know existed, and if this early galaxy turns out to be as real and as ancient as it appears, it could mark the beginning of a whole new chapter in cosmology. Another possibility Kaku raised was that we are misinterpreting what we're seeing, not in a conspiratorial sense, but in a deeply scientific one. Our understanding of redshift, which we use to estimate the age and distance of celestial objects, may need refinement. If the redshift values are being affected by unknown factors, perhaps related to dark matter interactions or quantum gravitational effects, then our entire method of dating cosmic objects could be off. This would mean that what we think of as an early galaxy could be something far stranger, a different kind of structure, or phenomenon we've never encountered. He even floated the possibility that we may be seeing echoes from a parallel epoch, a timefold, or time reflection, something predicted by certain models in string theory. These models suggest that under the right conditions, light or energy from other temporal domains could leak into ours, appearing as ghost images or impossible structures in deep space. This isn't fringe speculation anymore. It's being explored seriously in theoretical physics circles. And if Webb continues to find more of these anomalies, it could push these theories into the mainstream. Kaku compared this moment to the discovery of the cosmic microwave background in the 1960s. At first it seemed like noise, static from the edges of the universe, but it turned out to be one of the most important discoveries in cosmology, confirming the Big Bang Theory and giving us our first glimpse at the universe's beginning. He believes we may be on the brink of another such moment. The data may not make sense yet. It may be confusing and controversial, but it's real, and like all truly great scientific revelations, it's forcing us to confront the unknown. He also cautioned against rushing to conclusions. Science is slow for a reason. It's methodical. It requires time to digest, test, and retest. The images Webb has provided are just the beginning. We'll need years of observation, analysis, and peer review before we fully understand what we're seeing. But that shouldn't stop us from speculating responsibly, from dreaming big, from asking the dangerous, thrilling question, what if everything we know is wrong? The public, too, plays a role in this journey. Kaku emphasized that discoveries like these belong to everyone. The image Webb captured is not just for scientists in labs and universities. It's for all of humanity. It's a glimpse into our shared past and perhaps into our shared destiny. Every person who looks up at the night sky with wonder is now part of a story that is evolving in real time. And make no mistake, this is only the beginning. As Webb continues to scan the skies, more anomalies will emerge, more questions will arise, and voices like Michio Kaku's will be there to help interpret, challenge, and inspire. We're entering a new era of cosmic exploration, one that doesn't just seek answers, but invites us to rethink the very questions we're asking. So, where do we go from here? According to Michio Kaku, the road ahead is both exhilarating and uncertain. The James Webb Space Telescope has not just given us sharper images, it has revealed the raw complexity of the cosmos in ways we never anticipated. We're being asked to throw away the comfort of assumptions and face the possibility that the universe is older, stranger, and more dynamic than our models could ever express. Kaku believes that what we're seeing might be evidence of new physics. That could include modifications to general relativity at cosmic scales, previously unimagined behaviors of dark matter, or even interactions with higher dimensions. These aren't just radical ideas tossed around at conferences. They're real possibilities, forced into the spotlight by observations we cannot explain away. For someone like Kaku, who has long advocated for unified theories of everything, this is a dream scenario, data that demands new theory that demands new imagination. He also emphasized the importance of interdisciplinary collaboration. Understanding the implications of these images isn't just a job for astronomers. It will require input from quantum physicists, cosmologists, string theorists, and even philosophers of science. We may be on the edge of discoveries that redefine not only space and time, but also our understanding of existence itself. And it will take a global effort to unravel what's coming into focus. This new image, this seemingly impossible galaxy, is not just a scientific curiosity. It is a symbol of human progress, a reminder that we've built tools capable of reaching back nearly to the beginning of time, that we can decode the secrets written in ancient light, that we are part of a story that began long before us and will continue long after us. And as Kaku passionately put it, this is what it means to be human, to question, to explore, to be humbled by the vastness of it all. As more data rolls in, we may find alternative explanations that bring us back within the boundaries of known science. Or we may plunge even deeper into mystery. Either way, the James Webb Space Telescope has changed the game. The images it sends back are already reshaping textbooks, reopening old debates, and igniting imaginations. And the voice of Michio Kaku reminds us that wonder is not a side effect of discovery, it is the point. The shocking new image from Webb is a call to all of us to remain curious, to think boldly, to welcome discomfort, and to understand that truth often begins where certainty ends. In the face of this cosmic revelation, we are not just observers, we are participants in a grand unfolding. We are living in a time when the universe is speaking louder than ever. And now, with minds like Kaku's helping us interpret the whispers from the edge of time, we stand on the threshold of answers that may forever transform how we see ourselves and everything beyond.